Yeah, I run MIT's network. I actually got a phone call about it this morning. MIT's network, like many academic networks, belongs to the labs, departments, and centers when it works. They say things like, "How dare you tell us how to run our network?" But of course, when it's broken, it's my network. And that goes very deep. My call this morning was from a department that in the past had said, "We don't care about your centralized infrastructure for web serving. We don't care about anything you do. We'll run everything ourselves. Thank you. Have a nice day." To which my response is, "No problem." And this morning the call was, "We have a student who basically flunked out and he destroyed everything. Can you restore us from backup?" I said, "Oh yeah? Well, we're here today to talk about not backing up data, but having people other than the intended recipients listen to it." And let's see, where's the page down on this thing? Now, if you want to talk about interception, you got to sort of define what it is. And it's actually very interesting because if you actually look at various statutes, exactly defining what information is sometimes a trick. But what it is at its base level is the ability to listen in on traffic that, by the way, does not necessarily just go between two parties, but may go between any number of parties. And you want to intercept this traffic, you want to listen to this traffic, you want to view this traffic, and you want to do it in a way that the parties have no way of knowing that you're in fact doing that. So it should be completely transparent to them, it should be unknowable to them. By the way, doing this is really very hard in very subtle ways. I spent some time recently explaining to the FBI that if they get a mailbox that contains information that was intercepted, that they need to look at it with a text editor or print it, but loading it into an email client would be a mistake. Because if any of that mail was HTML with source image tags, when you look at it, you're going to do a hit against the web server. And so you got to be careful. Now, of course, the traditional case is a telephone wiretap, and of course, the modern case, I've seen laws, at least in Massachusetts, where they've said all communications, voice, video, email. They just want to cover the gamut. Right? If it's sent electronically or even carrier pigeon, they want to be able to see what it is. Now, there's several places you can do interception. I want to leave time for discussion, so I'll try to cover this pretty quickly. There's, as you know, the bit level, layer 2, IP, and the application itself. Bit level literally means there was a tool a few years ago called OC3Mon that actually could sort of glom on the side of an OC3 connection, steal some of the light. Now, that's a very good example of a tapping technology that you can't really know it's there, at least not once you're at any kind of an electrical level. And certainly not when you're at any kind of logical level looking at data packets. You have no way of knowing that somebody's siphoning off your traffic. But of course, the problem with doing this is as bits move faster and faster, you get a deluge of stuff. In fact, what a lot of the CALIA, the Communications Assistance to Law Enforcement laws passed a few years ago were all about, had to do with when the telephone network went digital, instead of listening into an analog voice stream, what would be on a pair of wires was a digital conglomeration of goop, and they had no way of sorting through it. And so this, and of course, the faster this goes, the harder this gets. Now, it turns out you can do this at layer 2. Layer 2 is, I'm sure you're all familiar with switches that have port replication. So you could basically command the switch that all traffic going to port 1 also send a copy to port 3. And then if you put a passive monitoring device on port 3, you're going to see all the traffic destined for port 1. Now, if you want to get two-way traffic, it's a little more subtle than that, but it's certainly easily doable. And at least at this level, you're not trying to decode the bits. Now at least you're presented with packets. And if the thing that you're replicating is a small number of computers, so if port 2, for example, on a switch goes to a single computer, then by port replicating that port, you will in fact get everything coming and going from that computer. So if that's what you want to do, you can certainly do that. Now you can do things higher than that. You can subvert routing. You can do something right at layer 3. I've actually not played with this. I've played with the others. But of course, if a router can implement a transparent web cache, a router can do this. And so this is another way of actually implementing this. You still have the problem that if you're looking at layer 3, you're looking at a lot of random data. The other problem you have if you're a law enforcement organization is you don't really care about IP addresses. If they're looking to get my email, they're not necessarily interested in traffic to or from any particular IP address. They want to get to traffic that's destined to me on whatever IP address I happen to be using. So, for example, if they want to wiretap Jeff Schiller and I'm at NANOG today, and I open up my laptop and I get a DHCP address, they need to know that so that they can capture my traffic. Oh, got ahead of myself. Oops. One of the subtleties with doing any of this sort of port replication or layer 3 interception is the computers you use to do this have to be faster than the computers actually communicating, because by definition you're going to get a lot more data. So just because you have a laptop or a computer with a 100 megabit Ethernet card doesn't mean that you're going to be able to successfully intercept all the traffic on 100 megabit LAN, even if it was all delivered to you. So you need to have overkill. So if you want to grab all the traffic, you need to have systems that are bigger than the intended systems. Now, by the way, how many people here are familiar with DSNF? Yeah. One of my favorite features in DSNF was the application called TCP Nice, which would insert interesting acts into a TCP data stream in an attempt to make it go slower so that you would get it all. I looked at that. Now, of course, that would not cut it for law enforcement, because that does have the property that you're injecting traffic and therefore you're doing something that's detectable. And they need to be indetectable. But I looked at that and I said, that's clean. I like that trick. Now, one of the spins on all of this is when you do various types of interception is what cooperation do you require from a vendor or for an internet service provider to do your dirty deed. Now, for example, if you were going to literally do something like an OC3 on tapping a fiber cable, one in theory could do that in a manhole in front of the ISP, and the ISP would never even know you're doing it. And for certain government agencies, that's exactly what they want to do, because they don't want anybody to know what they're doing. Now, frankly, tapping fiber can be a real pain. Can you say microwave link? Can you say 802.11a link out of this building? But I doubt there's any targets here. Tell a story, but I won't. Now, the most interesting form of interception is application layer interception. And that is when you actually bugger the application layer to do application data layer replication. Now, obviously, this requires significant cooperation from whatever's offering the service. But it's the most likely to actually grab everything. It's the most efficient in terms of computer resources. And in many cases is preferable. Now, how would you do that? Everybody familiar with SendMail's Milter facility? This is the SendMail interception facility, because you can certainly write a Milter that has the property that it looks at the headers of an incoming or outgoing email message or any email message going through SendMail, and if it meets a certain criteria, put a copy into a little file over here. Heck, you don't even need to use the headers. The Milter has access to the entire data contents. And if you have enough horsepower on your CPU to do spam detection and virus filtering, you have enough horsepower to do keyword selection across email messages and put copies into another file. So the technology to do this type of interception exists today. It's right there in the SendMail distribution. Just a little software needed on the side. But I can tell you from experience, it's not a lot of software. Similarly, if you are building web services, it's easy enough to arrange to divert any traffic or any transactions that might be of interest to law enforcement. For example, and by the way, I don't know this to be true, but if I'm Amazon.com, for example, it would be trivial for law enforcement to sort of say to me, every time Jeff Schiller buys a book, why don't you tell us what book he just bought? And that's certainly something they could do. Whether they do that or not, I have no idea. I have no way of knowing it, so I'm not trying to, disparage them in any way. But this is what I mean by application interception. Now, what's the goals of interception? This is where things get a little bit interesting, because what we're really looking at is a diversity of goals. Law enforcement, their goal is actually very simple. Reliable interception with maximum operational security. By the way, that's a term you hear a lot when you deal with law enforcement guys, operational security. Folks remember the old carnivore boxes and the whole carnivore debate of a few years ago? That was I think they renamed it something like DCS 1000 or some, Well, all I can think of was the carnivore, of course, was the FBI Internet Interception box. And when I first heard about it, I said, what idiot came up with that name? Because if there was never a name that would sort of trigger controversy, that was it.